Hi everyone. Um, Happy to be here and give the talk on the FlexiJoins. This is I think the most flexible, most featureful package for joining tabular, non-tabular datasets. Maybe not even just in Julia, but in general. So first of all, regarding tables in Julia, to set the scope for the talk, there are kind of two approaches how people use tables. First one is kind of like, what came from Python and R, that is using custom container types like DataFrames in memory datasets. Maybe there are other packages. And the second approach is kind of unique to Julia. You can use generic collections, mostly vectors, abstract vectors. It has some benefits, familiar performance model, composability, and here I show some examples just from base functions that correspond to typical tabular operations. So regarding joins specifically, custom table types like DataFrames, they typically have dedicated specialized join implementations. And again, typically, as far as I'm aware, they only support equality joins. So joining by key in one dataset equal to the key in another dataset. However, there are much more join types in general. So for generic collections, most like vectors, there is pretty old but still working package, split apply combine.jl. I actually contributed to it a bit like several years ago. Now it's badly maintained, I would say, and it also only has key equality joins. And I created FlexiJoins in 2022. The aim here is to support all kinds of datasets, all kinds of joins with a performant and uniform interface. So since the release in 2022, there were no breaking changes, so it's still on the there was no kind of breaking version bumps, no breaking changes at all. Maybe there will be at some point if the current interface doesn't work out, but as of now, it's been pretty stable. It already supports all kinds of joins, like key equality, of course, A's of joins, interval joins, joining by distance, combining multiple different conditions, left, right, inner, outer joins, group joins. And the design goal that has materialized is that it's fast, as in it never falls back to just looping over both datasets and selecting matches. So natively, with just generic code without any special handling, FlexiJoins support all kinds of Julia collections, abstract arrays, tuples. If you have very small datasets, tuples in inner loops can be very fast. Dictionaries, type tables, .jl, and like everything else, anything else that supports a collection interface. I personally don't use DataFrames, but I got a few feature requests. It's like several people requesting to add this compatibility several years ago. So I added them. We are a sync compatibility layer because DataFrames don't support the kind of general collection interface. So it's like basically 10 lines of code to convert them to struct arrays and convert it back the result. So in this talk, I will show a few examples demonstrating the interface of FlexiJoins, how to use it, and then I'll briefly explain how it works and how it's designed and what are the kind of limitations and missing pieces for now. So starting with the basic interface. So the main entry point that you generally use is just the inner join or the corresponding equivalents for left, right, and outer joins. And basically, you call it as inner join with two of your data sets and the predicate. Here, it's a very simple example. You have just two tables, table of objects and table of measurements, and you want to just match every object with its measurements and specify the by key match and matching by name. This is a typical kind of key equality join. The result is really the collection of tuples containing an element from the left side and from the right side. It is almost equivalent to this list comprehension at the bottom, just faster, just optimized. So when you think of what FlexiJoin returns, it's basically this collection. For convenience, so I typically, when I'm running FlexiJoins, I use named tuples instead of tuples. So you can name like left side and right side with some typically short single letter names, but anything works. And it makes it the result kind of easier to use, because now in the result you don't just have tuples, you have the kind of O and M the same named the same way as you name the input elements. This is just more convenient for any kind of downstream analysis. One of the kind of neat performance features that wasn't even very difficult to have is that it's FlexiJoins by design. It doesn't copy your kind of data from original dataset. Whenever possible, so like for basically any array, it returns views of the original dataset. So J is the resulting collection from an inner join, and you see that it just contains. It's a struct array, so it contains a collection of elements from the first collection, from kind of the left side and from the right side, and they are not copied collections. They are really, as you can see, they are views of your original data. This is kind of important for efficiency if you have large data sets, and maybe with like 10, 20 columns, you don't really want to copy all of these to the join result. So after you get this kind of joint collection, there are several kind of typical ways how the processing can go downstream. First of all, if you really need a flat table in the end, not just a collection of like tuples and named tuples, you can just call the Julia function merge, because each element in the collection after joining has two elements, one from the left side, one from the right side. With merge, it will just merge all the columns. But typically, at least for me, it's not how I generally do the processing after joining, because it's very convenient to just do whatever operation you wanted next while keeping the while having the names of your left and right side to avoid any confusion. So here, at the bottom line, at the very bottom line on the slide, it's clear where each column comes from, whether it comes from objects, from measurements, or if you have some combination of those, it's really kind of makes it cleaner than just merging everything into a single flat table. So this was a brief kind of intro into the interface using the just key joins as an example. But as I said, a major part of FlexiJoins is supporting like a wide variety of join conditions. So, for example, this is how you would write a join by kind of like column in one data set less than a column in another data set. It's still fast. It still doesn't fall back to nested loops. You can join by distances. So most of the distances from distances.jl just work for both numbers, for vectors. When needed, so for vectors, it creates a search tree. So everything is also stays performant, and it is the same syntax. You specify what to merge. Like in this example, I shows that you can merge two data sets. I mean, the same data set with itself, finding different measurements that are within some time distance from each other. There are all kinds of interval conditions. So first of all, here I also highlight that FlexiJoins everywhere. It accepts arbitrary functions, not just column names. So here maybe you want to create an interval specifying like, okay, I want to find measurements that are timed from my kind of reference time to the reference time plus 10. And for that, you create an interval. It is from interval sets. I think the most popular package for intervals. Yeah, and all of these operators here are supported for intervals, and again, everything stays performant. Of course, you can combine multiple conditions. So here, it shows the same conditions that we had on the previous slide, but we add the by key name. So now it does. So before we had measurements and matched with all kinds of objects just based on time difference. Now it is both the time difference and the same name. So all the conditions really, at least most of the conditions work together. Of course, sometimes you can stumble upon like a combination that is not supported in an optimized way, and then it will error. It will never fall back to nested loop joins unless you explicitly ask for it. So performance is saved by default. Another neat thing is that sometimes you want really all matches. So that's what you get by default. You want all matches with measurements after the reference time. Here in the example, sometimes you only need the closest, and for join conditions that have a kind of for which saying closest makes sense, it is supported as a kind of multi-argument. You specify like which data set to take the closest from, and everything also just works and works performantly. So these join conditions that I walked through, they are just available in FlexiJoins itself, but it's designed to be extensible, and it is. There are other across the ecosystem. These are the ones I know. So there is joins by just by uncertainty in the uncertain.jl package for uncertain numbers. Basically, if you have two data sets with like uncertain numbers, and you want to match those that fall within their errors. In geometry ops, they added geometry predicates, I think mostly for kind of 2D geometries where you have like some polygons that contain each other and provide some tree-based optimized joins as well. And it also didn't take. I checked on their implementation. It didn't take many lines actually in the extension. And so I'm doing astronomy. So I added the join for sky coords objects when you have like two catalogs of sky coord coordinates and want to just match them, like cross match one to another. It also works. It also is based on trees. Another thing that is not really kind of necessary to use FlexiJoins, but I find it generally useful, is that when you kind of intuitively expect that you will get like one-to-one join, so all the matches should be unique and all elements should match. Sometimes like you run it, you check that it's okay, but then your data changes and someone adds a duplicate somewhere, and you only catch it somewhere downstream. So if you really want a one-to-one join or any other kind of like cardinality constraints, just pass the cardinality argument, and it will error whenever you get kind of non-unique or non-existing matches. When it's not when cardinality is not specified, it doesn't affect the join. It will return whatever matches you have. But I find it very useful whenever I know that I want a one-to-one join, or like or 0-to-1, for example. Like so, and there have to be unique matches, but never several. Yeah. So this is about kind of like the overview of the functionality. Regarding performance, so this is just a quick benchmark from a notebook that's available in FlexiJoins repo. It compares DataFrames, FlexiJoins, and split apply combine. Of course, it only compares key equality joins, because other packages don't support other join conditions. So there are kind of several regimes for very small collections, like less than 1,000 elements or so. FlexiJoins tends to be the fastest all over the board, and this is useful if you have a join in a tight loop. This is, I mean, nothing wrong with that. Maybe you have an optimization loop or sampling loop or like some other Monte Carlo simulation and run a like a kind of short join with 100 or 1,000 elements. FlexiJoins is generally the fastest for it. As soon as we get to larger, so sorry if the labels are small, the left plot is time on the vertical axis versus the total dataset size, like sum of the dataset sizes on the bottom. Middle one is the bytes on the vertical axis, bytes allocated, and on the right it's number of allocations. So now I'm talking about the leftmost plot. At the larger sizes, both packages, like first they start being like roughly equal. At very large sizes, I think DataFrames typically gets faster. They have like very optimized implementation for many cases. But again, this is so neither DataFrames nor split apply combine support other kinds of joins. So it's nice that with the generic implementation, we in FlexiJoins can be really well competitive with more dedicated specialized solutions. So benchmarking notebook available in the repo. You can like tweak it with different sizes and run it as well. So Then a few words on how it works. So how it's designed and how it works. Basically, this is how the join process works. First, FlexiJoins looks at the condition, kind of interrogates it, what modes are supported. Basically, like hash join, sorted join, tree join, but it's extensible. It can be kind of all kinds of stuff. It's just that for now, it's only these three are actually used anywhere. Then it chooses one side of the join to so-called prepare it. So basically, if it's a hash join, it will create a hash table like dictionary. If it's sorted, it will sort one side and so on. Then it loops over the other side of the join, for example, on the right side. And for each element in the other side, it's typically chosen to be the smaller side for performance. It finds all the matching elements in the first side and the left side using the prepared lookup. So it is really kind of efficient, and also the choice of the which one to prepare and which one to loop over is reasonably clever. Yeah, so it calculates for both matches and for non-matches if needed. It just computes the indices of matches, and in the end just creates a view based on these indices, returns a view, and that's what you get as a result. I think the most kind of maybe not the most interesting thing in general, but the most interesting thing for those who want to add more join conditions or learn how they work. So, like in the very base case, for each condition, you need to specify what modes it supports, like hash joins or join, and implement the kind of function to prepare one side of the join and like optimize it in some way for lookup, and a function to find matches in that prepared lookup. Here's like an example for sort mode, really, and for sort mode, there are some convenience functions that are generic for all conditions. So the bottom two functions there don't need to be implemented for every condition. But generally, it's very short implementation. There is nothing really tricky about it. The function names can be, function names can be improved. They were kind of just created first, and I didn't want to break stuff afterwards. And really the aim that seems to materialize in the recent, especially in the recent year or so, with more packages, with at least some packages, adding support for joining with FlexiJoins. Really, one of the aims is not just performance, but make implementing new conditions easy. So this is just another example where you add. This is basically how by distance join is implemented in FlexiJoins. It uses nearest neighbors .jl to build a tree, and then search in the tree. So it is really not a lot of code. And I promised to say a few words about limitations and what's currently missing. So I think there is nothing kind of major in my view. It works, it is performant, but there are some things that can be improved. So first of all, as I said, now FlexiJoins optimizes, kind of prepares only one side for lookup, and just purely loops over the other side. There is a flexible choice. It can depend on your condition. If you want to customize it, which side to loop over, it can be beneficial to change it from default. But sometimes it makes sense for both sides to be optimized. The most prominent example is the sort merge join in relational databases. So you sort both of your data set and then just linearly merge them together. This part is not implemented for now. The main kind of questions here are where should the extension points be for this mode. Also, for now, it uses generic algorithms. So it uses like just the Julian sort function. For hashes, it uses Julian dicts. For trees, it just uses nearest neighbors. This works great for performance, as in the performance never falls back to n squared. But special cases can be optimized more. Most notably, like if you there are a lot of common cases. Like keys are an integer in a specific range, or you have a pooled array with or categorical array with not too many distinct values, or kind of just small integers. This all can be optimized, and it won't change the kind of asymptotic behavior. It will still be kind of like hashing, for example, or sorting, but it can make the joining several times faster for some cases. This is actually the reason why data frames are faster, because they have a lot of special cases, so many that I think like many cases now happen to be special for data frames, but only for equality joins. So also regarding documentation, not a very uncommon issue, I would say, in Julia packages. But yeah, documentation exists, but it is kind of sparse, definitely. Um, I don't know, like from time to time I extend it a bit, but it takes, I guess, some effort. So to sum it up, FlexiJoins.jl. This is the ultimate package, in my opinion, for joining datasets. Works for tables, and not just for tables, for arbitrary collections in Julia, collections of arbitrary objects. Anything works. Very wide selection, the widest I can remember seeing in any library, of join predicates, join conditions, and everything with just a uniform and performant interface. I think it is really the most feature-rich package for joining. And yeah, thanks for your attention. Happy for questions or discussions now or afterwards. Thank you.
Questions from the audience?
Hello, thanks for the talk and the package. Have you compared the performance or done a benchmark with SQLite and DuckDB?
Oh, I haven't, because first of all, kind of like, if you have a Julia table for SQLite specifically, you probably need to somehow like load it into SQLite. For DuckDB, they can read the columnar Julia tables as is. Yeah, at least when I developed it, it wasn't the case. I don't think there was a Julia binding for DuckDB then. I think that DuckDB, I mean, for the joins that they support, they should be pretty fast. But they only support flat tables, not arbitrarily Julia collections. So here it is like Julia first.
Okay.
And it's not just kind of like for container types. It's also like for geometry types, interval types, sky chords. It's hard to get in a non-Julian software.
Okay, thanks.
Any other questions?
Hello, thanks for the package. You mentioned support for DataFrames. Is that coming soon, or is that already available? And secondly,
Yeah, it's been available since probably the end of 2022. And when 1.9 came out, I just moved it to extension. So if you don't use DataFrames, it's not even loaded. If you use it, it just works.
okay, and
And
why?
it is regularly tested. So even though I personally don't use it, it is in the CI and in the tests.
And then related to that, why is the for the DataFrames extension? Why do you have to convert it to struct arrays and then back again?
Yeah, so all the types that are kind of natively supported, they follow the same interface. They are just collection of Julian values. That's why they don't need any special handling. Then DataFrames has a very different interface. That's why it just doesn't just work with the generic code. That's why it's either converting it to something, and struct array is nice because it's also columnar, so the data is not copied when the conversion happens. But if not conversion, how else to have this? Like,
Okay, thanks.
yeah.
Any other questions? I will make a. In the meantime, the next speaker can probably, I think, set up. You mentioned that you use designs like less and higher than. What are they for? I don't know if I follow.
So if you want to find like all matches in the second table that come after, like later in time than values in the first table, or if they fall in some interval, or you want the closest match that happens after your event. Yeah.
Thank you very much.